In this lesson, you will be able to recognize the properties of identity equality and use those properties of identity and equality. How are identity equality properties used to compare data? During the college football season, teams were ranked weekly. The table shows the last three rankings of the top 5 teams for the 2000 football season. The open sentence below represents the change in rank of Oregon State from December 11th to the final rank. On December 11th, it looks like they were 4th, plus an increase of rank, they named R for rank, equals the final rank for the season of 4. The solution of the equation is, of course, 0. Oregon State's rank changed by 0 from December 11th to the final rank. In other words, 4 plus 0 equals 4, and we'll want to name the property that applies to. Your identity is who you are. So the additive identity for any number A, the sum of A and 0 is A. So if we add 0 to anything, or 0 is added to anything, we get what we started with. So in the word problem we just looked at, the property used was the additive identity. So the multiplicative identity is multiplying by 1, because when we multiply by 1, it doesn't change the value of the number. So any number times 1 or 1 times any number, you get what you started with. The multiplicative property of 0, for any number of A, the product of A and 0 is 0. So it doesn't matter which one comes first, we always get 0. And the multiplicative inverse. And it's also known as reciprocal, but for properties we're going to name it multiplicative inverse. For every number, A over B, where A and B do not equal 0, there's exactly one number, B over A, such that the product of A over B and B over A is 1. So they did it with the numbers over here. 2/3 times 3/2, 2 times 3 is 6, 6. Okay, 6 over 6 is 1. We could have also done that by canceling, because if we canceled out the 3, and it's the same thing because we're doing 3 divided by 3 is 1, 2 divided by 2 is 1, we get 1 times 1 over 1 is 1. So more than one way to get the same answer, but multiplicative inverse, product of any number and its reciprocal, is always going to be 1. So the common thing they're going to have us do in this lesson is find a value for the variable and then name the property that could be used to find that. So in the first example, they have n times 12 equals 0, and we know that to get a product of 0, we're multiplying by 0. And they want us to name the property. Well, multiplying by 0, that would be the multiplicative property of 0. Now, in the book's directions, they switch the order and they ask to name the property first. I think for most students, it makes more sense to evaluate, find the value of n first, and then name the property used. We may need to look back at our notes to see what our choices are for properties, but we've been looking at these for a number of years, so it should be all right. Hey, this time I'm multiplying two numbers and I get a value of 1. So that's going to be, looks like this guy, I'm getting a solution of 1. So it's going to be the multiplicative inverse. The multiplicative inverse of 1/5 would be 5 over 1. Since we know 5 over 1, or 5 times 1/5 equals 1, and the property used was multiplicative inverse property. And we want to find out what number, if we add 0 to it, we get 8. And that's going to come very quickly. We know that n has to be 8 because 0 plus 8 is 8. And then the property used, well, that was our first one, the additive identity, because we're adding any number, in this case A, plus 0 equals A. And we have 4 more properties we get to practice today. The reflexive property says any quantity is equal to itself. You look in the mirror, who do you see? Hopefully yourself. In symbols, they wrote A equals A, or 7 equals 7, 2 plus 3 equals 2 plus 3. So they've done nothing. The symmetric property says if one quantity equals a second quantity, then the second quantity equals the first. Okay, so basically they're just switching the order. If A equals B, B equals A. So you're used to symmetry in geometric type figures. 9 equals 6 plus 3, 6 plus 3 equals 9 is what it would look like in an algebraic equation. Transitive property, we're transitioning from one thing to another. In words, they say if one quantity equals a second quantity and the second quantity equals the third quantity, then the first quantity equals the third. Okay, it makes a little more sense here. If A equals B, then B and B equals C, then A must equal C. So with numbers, they did 5 plus 7 equals 8 plus 4, okay? Then they moved the 8 plus 4 to the front, so 8 plus 4 equals 12, yeah. So then 5 plus 7 must equal 12. Substitution says any quantity may be substituted for its equal in an expression, and we see that in sports a lot. We have substitutions in most of our sports, or in cooking. If you don't have what you want to have, there are substitutions that can be made. I'm not sure that in baking or in sports substitutions are completely equivalent, but in algebra they are. If A equals B, then A may be replaced by B in any expression. So if n equals 15, then 3n equals 3 times 15. They just put it in. Now substitution they use a lot. And you'll see substitution come up a lot in this one problem. So they want us to evaluate the expression that you've been doing for a long time. Name the property used in each step. So this is kind of getting us ready for the idea of proof in a way. We're saying why we do what we do. So in the world of PEMDAS, we would start inside our parentheses. So they said 12 minus 8 is 4. So they substituted a quantity for its equal. Substitution is the name of the property. The next thing we do with PEMDAS is divide 15 by 5. So that's also substitution. Sure enough, 3 minus 2 is 1 is still substitution. Finally, we get a branch out. 1/4 times 4 is 1. That's multiplicative inverse. And 3 times 1 is 3, multiplicative identity, anything times 1 is itself. And our last step is, of course, 1 plus 3 is 4, and we just added, so that is substitution. So even though this only counted as one example, it was really 1, 2, 3, 4, 5, 6 separate little identify which property we're using, so it's kind of 6 problems in one. So the first thing we would do with PEMDAS is 10 minus 7 is 3. We just subtracted, so that's substitution. And I abbreviate a lot. 18 divided by 9 is 2. So again, substitution. And you can be free to abbreviate as well. 2 minus 1 is 1. Once again, nothing special, just a substitution. Now, 1/3 times 3 is 1. That is one of our special properties. That is multiplicative inverse. I abbreviate that mult-inv. And then we can multiply 4 times 1 is 4, and that's multiplicative identity. Anything times 1 is itself. So I abbreviate that mult-id. And finally, 1 plus 4 is 5, and I just added, there's not another special property I can use, so I'm going to call that one substitution once again. So we have 4 reasons that are substitution in the same problem. Quick summary then here, adding 0 to a quantity or multiplying a quantity by 1 does not change the quantity. Those are our identity properties. Using the reflexive, symmetric, transitive, and substitution properties along with order of operations helps us in simplifying expressions.